All right, guys. So today we're going to do 1303 from Maths in Focus. Now, this is like solving dy dx equals f of x and g of y. You probably expected it was coming because first it was f of x, second was g of y, and now it's together. Example 7. We're going to do direction field for it. Now, this is going to be a little bit tricky, obviously, because we have to deal with two things at a time. So I thought it might be better if make it into like a point, like coordinates. So x and the y, I just put it in as a, we're still going to use the table, but I thought x and y, because now we have to do like two things all at once. So I'll just put it as a, like a point form, like, coordinates. I put here it's y equals 0, what will happen, and this one second points here and when x equals 0. Now both of them, the gradient, the m dy dx equals 0. So that's there's like turning points there. So what I've done on the left hand side, the graph, you can see x-axis and y-axis, I made it into flat. They are like turning points. And then, now, this is going to be a tricky one. What I've done, it's going to be like long one to see any kind of reaction or activities there on a direction field. So just to see briefly, I just put two values each, just 2 points each from each quadrant, if you like. So the first one, 1 and 1, 1 and 2, is obviously the first quadrant. Okay, so that's a first quadrant. I'm going to put 1 there. And then 1 and minus 1, 1 and minus 2 is obviously fourth quadrant. Oops. And then 2 and 1, 2 and 2 is still first quadrant. The reason I put that in there is I want to see the difference, what happens with when x equals 1, when x equals 2. We need to see the, how steep the gradient's going to be. So I'll put that in there. And then minus 1 and 1 is the second quadrant. And the last one is a third quadrant. Okay, now it's not going to be same direction and same stiffness all the way through when even the x value is the same. Like if you see it's a first quadrant and fourth quadrant, they have x value equals 1 all the way. But if you look at the values here, when x equals 1, y equals 1, and y equals 2, there is going to be steeper. So what I've done here, it's in the pink line here in a 1, it's slowly growing and going to the vertically. But then when you look at the x equals 2 here, when x equals 2, a lot quicker. See, it says a 12 and the next one is 24. So when you look at the graph here on a 2 here, it's almost like a vertically, going up. All right, so that's what I've done. So as you can see, because of our equation here, okay, equation here, you can see the x squared there. So when the x gets bigger, the gradient will get it really big, huge, and steeper. So after 2, I mean, we can't really see any much of changes at all. It's just going to be straight up. Okay, so that's what I've done. And when you look at the second quadrant, here, right here, that one, it's the same as the first quadrant, as you can see. Okay, so 3 and 6, the gradient for the first quadrant. Second quadrant, here 3 and 6 as well. So that means they're going to be on the same direction. So when you look at the x equals minus 1 here, it's the same as x equals 1. Okay, same direction. And then same stiffness. So it's the same thing. Now, when it's a minus 2, I didn't do it here, but it'll be the same as well. So that's orange part here. Now, what will happen then when y is negative? Now, it doesn't really matter with x here so much, isn't it, with gradient equation here, because it's going to be squared. But y will make a difference here with the direction y's, because that's just y, not y squared. So if I just look at fourth quadrant right now here, it's when x equals 1 and y equals minus 1, minus 2 here. And when you look at it, there you go. It's opposite direction, isn't it? So it's minus 3, minus 6. When it was in the first quadrant, it was 3 and 6. But fourth quadrant becomes minus 3 and minus 6. So it's opposite direction. Okay? So what I've done here on x equals 1, and then I'm looking at fourth quadrant right now, they are opposite direction, but same sort of steepness. Okay? And same thing will happen when x equals 2. Okay? I'm looking at here. They will get like really getting bigger, steeper. Okay? So when you have time, you can make a big table and put various points from each quadrant, not just 2 points maybe if you have time. Oh, there you go. That's the much neater version of it. So as you can see, the green part is the fourth quadrant and the third quadrant, and then the blue one is the first and second. You can see the blue first and second quadrant, they are in the same direction, and then green one, third and fourth, is opposite direction. Okay. Before we go on to the example 8, now because we got to deal with the x and y at the same time, think about it, we got to separate them, isn't it, somehow? So basically, we need to put whatever we're going to integrate, dy on the left, dx on the right. So if we can sort of make some sort of rule about that. So now, example A is not something that we have to solve or find. It's just asking us whether it's a separable, which means whether we can put all the y's on the left hand side or the x's on the right hand side. Okay, so let's have a look. Dy dx equals 2x 5y cubed. So y on the left hand side and the x on the right hand side. So I'm gonna, if you want to, you can just do times by 5y cubed. So that will get rid of it y expression on the right hand side. So I'll have 5y cubed dy here, and I still have dx left here, and then I have 2x here. Okay, dx to the other side. So I'm going to do that. If I do that, I will get 2x dx. Okay, so I mean, the more you do these kind of questions, you don't really need to do this times by y expression times by dx. You can straight away, you can see it. Anyway, so that's separable, right? We already put that into left hand side and right hand side, so it's okay. This one's okay, so we're separable. Now, part B, when you look at it, okay, so if I put dy dx equals, I've got xy, it was there on the right hand side, minus sine x. Now, I cannot really separate this because it's got two terms here. Okay, only times you can separate is when it's on the one term's on the left hand side and then one term's on the right hand side. So, no, it's not separable. And then let's have a look at the third one, part C. Okay, this looks okay to me. So x dy dx equals 2y. Okay, and then if you want to, 2y over x, and then we do the same process if you want. Okay, so I will go, I'm going to move 2y on the other side, so it's going to be dy 2y, because 2y, I move to the other side, it'll be the fraction, and then 1 over x left on the right hand side, and then I'm times by dx. I've done it in a different way, so if you prefer step by step, please have a look at the what I've done on the part A, and then you can do that way. So it is separable. We can do that. That's not a problem. So C was okay. So we are going to now solve. Remember, solve is anything to do with a solve is y equals whatever. Okay, so I'm going to do that now. First step we have to do is we have to separate. Okay, that's why the example 8 was all about. So that was helping us to practice. I'm going to separate this 2x over y squared. So I'm going to move y squared to my left by timesing y squared on both sides. So it becomes y squared dy and 2x dx, because I times by dx on both sides. Okay, so think about that, and I'm going to integrate. Okay, so I'll do that. Okay, and we just integrate plus C1. I'm going to go here because we've got to do integration at the same time. So square. Now, so we got too many like constants happening here. So what I'm going to do here, I'm going to sort of tidy it up a bit. So y cubed 3 equals, because we want y equals something, okay? So what I've done is I'm moving my C1, my constant on the left-hand side to the right, combined with the C2, which is still going to be constant, isn't it? So x squared plus, I'm going to put a k because that's what the textbook used. You can use anything. You can put like, A or B or something. And then, or C3 if you want. And then I'm going to make this into y cubed, the subject. So that means I'm just times by 3. Okay, so it'll become 3x squared, and I'm going to change this again to capital C. Okay, so capital C is like a 3k really, but it just looks neater if we just put just into one whole constant. Okay, and then what I do, therefore y equals cubic root of 3x squared plus c. Equation there. All right, so that was my original equation. Step 3 here as making the y the subject. Okay, so that's 3 steps to go through. Now, example 10. Okay, similar, but extra step, which is Now we don't have to deal with about constant here, because we will find the constant and when we use the x and y values there. Okay, so first step, we're going to separate them. So I'm going to separate straight away. So it's going to be dy over y. Now think about that, how I did that. I moved the y on the right hand side to the left, so it becomes 1 over y. And then what I've got left is on the right hand side 3x squared dx. Okay, and then I'm going to integrate. Okay, on the left hand side, 1 over y, it's, ln. You should have that in your head before we're starting. Okay, C1. And then I'm going to integrate this normally, something like that. And I'm going to tighten it up a bit. X cubed plus k. Okay, so that wasn't too bad. We have 0 and 1. All right, so I'm going to put ln y was 1 equals 0 plus k. So therefore, my k is, that's 0, guys. K is 0. So my equation is ln y equals x to the power of 3. Okay, now we need to change this into, so y the subject, but we want it to y equals. So to get rid of ln, we do e. So y equals e to the power of 3. And that's my original equation there. I think it's the last one. Oh, very similar to what we did the other day. So let's have a look at A. So f dash x, I can change that to dy dx equals x squared over y. Okay, I'm going to change into all the y's on the left hand side, all the x's on the right hand side. So I'm going to do it straight away. Here, I think you can just do cross multiplication here, right there. X squared. Or sometimes you can, okay? Sometimes you can, but sometimes you can't, because what happens if this was y over x squared, then you can't do cross multiply. But this case was very lucky for us. We can do it straight away. So that was the first one. We separated. Second, I'm going to do integration. So y dy x squared dx. So that was, we do this straight away instead of doing C1, C2. Okay, and that's what I've got. Okay, and then I'm gonna do the making the y the subject. So what I'm gonna do here, times by 2. Okay, times by 2, I'll get 2 over 3x cubed plus, I'm going to make it into big C. Okay, C was a 3, or the K, it was like a 2K, become 2K, but I'm going to make it into C. C is a constant. Now, therefore, y equals, I have plus minus, put all that in, Q plus C. So you get 2. Now, luckily, we don't have to worry about the condition. Like the last one, we had to worry about the condition, but this one didn't have any condition. So we will have end up with just two original equations, say f of x. Oh, actually, it's better if I put f of x, isn't it? Yep. So after you've done a y equals whatever, maybe change that to f of x equals plus minus root square root of 2 over 3x cubed plus c, because question was in terms of f of x. Okay, so that was what it was. There's a condition right there. So last time we sort of had to remind ourselves again at the end. So this time, let's see how we go. All right, so I have, and also I can just put 3 and 2. That's the point that we got, so we can find the constant at the end. So let's have a look at that. Actually, this is what we're using for B, isn't it? Because that was a general solution, and we're going to find the solution with this point. Okay, that's right. So it's continuing that. Now, we need to think about this is special condition. When you put the f of 3, we're getting negative 2. Okay, so when we look at our f of x from part A, we got plus minus 2 over 3x cubed plus c. Now, obviously, we need minus, but we can't really have minus with a square root unless we have minus in front here. So only thing that we can use satisfied is, therefore, f of x has to be negative 2 over 3x cubed minus plus c. Okay, that's only thing is satisfying the solution. Okay, I'm going to just use this. Okay, and then use the point, the 3 and 2, to find c. Okay, because it says find the solution, so meaning we have to find the whole thing, like without any unknown values, like c here. So what I'm going to do here is I'm going to 3 and minus 2. So I'm going to go minus 2 equals minus 2 over 3. X was 3. So before I do anything else, I'm going to tie this one up. So 2 over 3 times 27. Okay, 27. So that's, and then you divide it by 3, it'll be 9. Okay, so it'll be 2 times 9 is 18 plus c. Now, how am I going to find the c? I'm going to squaring it, both sides. Okay, so and that will make me 4 equals, make this 4 and then 18 plus c. So therefore, my c equals minus 14. Okay, because I'll move the 18 to the other side. And therefore, my solution is, I'm going to write this time, f of x, because that's what it is, equals, I'm going to write it here, negative, guys, negative 2 over 3 x cubed minus 14. Okay, hopefully if you had more space, if I had more space, I could write it in one spot there. Okay, so that's what it is. That's all for this lesson. All right.